The next question is, express 4x squared minus 12x in the form 2x plus a all squared plus b. So when you look at the first part of the question, you see this is the quadratic equation given because x is raised to the second power. And we need to convert this form to the vertex form or completing the square form. This is looking like completing the square, but it's not exactly the same because here the coefficient of x is 2. It's not 1. Therefore, we can actually start converting this quadratic equation to the completing the square form. Then we are doing a technique in order to get this number here. Okay, so let's start with the first part. We have 4x squared minus 12x. And this is in the form of a function. It's not an equation in this form. Therefore, we need to consider the first and the second term, which are including the x variable. So the first step is to make the leading coefficient 1. The leading coefficient in this form is 4. Therefore, we need to take out 4 in order to make the leading coefficient for x squared 1. Then minus 12, it's like 4 times 3. When we take out 4 as common factor, then 3 will be left here. Then close the squared interval. The next step is to change the quadratic function inside the square bracket to completing the square form. So we directly open a square parenthesis, then take the square root of x squared, and look at the coefficient of x. It's -3 and divided by 2. -3 over 2. Then at the outside, you should subtract the square of 3 over 2. And then we can now simplify this further. It becomes 4 times x minus 3 over 2 all squared, then minus 3 squared is 9 over 2 squared is 4. And if you look at this form, you see it's not exactly the same as given in the question, which is requested to do so. Therefore, we need to multiply this 4 by the terms inside the square bracket in order to get such a form. We can say it's 4 times x minus 3 over 2 all squared, then minus 4 times 9 over 4 is just 9, because you can cancel 4 with this 4. However, for the first term, we have 2x, but here inside the bracket is not 2x, it's just x. Then how to make it 2x? We need to think of changing this number 4 to another form. We can say 4 can be something like 2 to the power of 2. Then times x minus 3 over 2 squared minus 9. So now this 2, the base is 2, and the power is 2. For this parenthesis, it's also raised to the second power. Then we can combine these two, or simply you can multiply the base, which is 2, by each term inside the parenthesis. So it becomes 2 times x, then minus 2 times 3 over 2 is minus 3, then all squared minus 9. Now look at the formula here. You see that it's exactly the same as requests 2x plus a all squared plus b. Therefore, a and b parameters are, you can say, therefore, a equals to -3 and b equals to -9. Now the second part of the question, hence or otherwise find the set of values of x satisfying for x squared minus 12x greater than 7. So if you look at the left side of this inequality, you see that it's the quadratic equation that we solved or simplified it in the first part. Now we need to solve this quadratic inequality. And a rule that's always applied for the quadratic inequality is the right side of the inequality must be 0. And if it's not 0, you need to make it 0. this is the first step. You can start with solving the quadratic inequalities. So when you look here, you see that it's 7. Therefore, we need to change it to 0. Therefore, for the second part of the question, when you write down 4x squared minus 12x is greater than 7, you have to add the negative 7 to both sides in order to make the right side 0. So you can say it's 4x squared minus 12x minus 7 is greater than 0. And in order to find the possible values for the x that satisfies this inequality, such that the function on the left side is larger than 0, that means the value for the function must be positive, then the easiest way is to sketch the shape of the curve for this function on the left side. How's the shape of this curve? As long as the leading coefficient is positive, therefore the shape of the curve should be a concave up curve. Okay, now we know that the shape of the curve is like this. However, we need to find the roots for this function in order we sketch the x-axis and to find the critical points, which are the x-intercepts. Okay, in order to do that, we need to factorize this on the left side. So we can think of factorizing the left side into 2 factors. Then we have 4x squared. We can say 4x squared is like 2x by 2x. Okay, there is one possibility to factorize 7, which is 1 times 7. If we put 7 here and 1 at here, then this is positive times negative is negative, negative times is positive. Then we need to check if we can get the middle term or not. Negative 7 times 2x is negative 14x. Then 1 times 2x is positive 2x. Then the total of these two is negative 12x. So you see that equals to, or it's the same as the middle term. Therefore, this factorization method is working. And then we need to identify the roots for the function on the left side. We can simply draw x-axis. And when we are looking at here, we can say one of the roots for the function on the left can be x equals to 7 over 2, or x can be negative 1 over 2. Because when you send this one to the other side, it becomes negative, then divide by 2. Negative 1 over 2 is one of the roots for the function, and 7 over 2 is the other root. Therefore, the two x-intercepts that the curve making with the x-axis are, the first one is negative 1 over 2, the second one is 7 over 2. If you look at this curve, you see that this is the x-axis, and of course below the x-axis represents the negative side of the function. The values are negative here, down of the x-axis. However, above the x-axis, it represents a positive value for the curve or for the function. Therefore, the solution for the inequality is located in these two regions, starting from negative infinity until negative 1 over 2. Or you can say when the x value is less than negative 1 over 2, moving to the left side, then the function becomes positive. That's why this region is one of the solution set. And here we also have another solution set which starts from x to be larger than 7 over 2, moving towards positive infinity. Therefore, we can say the solution set, therefore, the solution set of x values is, we try to give the solution for the x is the set of x that are element in the real numbers, such that you see that x can be less than negative 1 over 2, or another solution is where x is larger than 7 over 2, then close the set.